Hi, I'm Philip, and in this video I will talk about the accuracy of the Revopoint Trackit in marker scanning mode and in tracker scanning mode. So for the scan setup, it is quite common to the previous tests I done of the accuracy. So basically I placed the micrometer on my trusty turntable, and marker geometries were used around the micrometer. So these here, so they are basically 3D printed hexagons. I think there are dodecagons with markers on them to allow more shallow scanning angles. And while scanning, the turntable itself was not rotated to prevent marble of the parts. For tracking mode, so if you have the Revopoint Trackit, you can either use the handpiece for standalone scanning with markers, but keep in mind you still have to connect the handpiece to the tracker and then the tracker to the PC, or you can use tracker mode where the tracker itself is tracking the handpiece. So basically you have the small 3D scanner for the actual part, and then you have the big 3D scanner that only tracks the handpiece. While scanning, I also use scan spray. So the micrometer itself was calibrated to 125.00 millimeter plus minus 0.01 millimeters with like a calibration gauge or calibration part. And since the anvil and the spindle, so this part and the other part are polished to a mirror finish, I had to use scan spray on both sides. For this, I just used a thin coat of Acer Blue. The thickness of Acer Blue is per manufacturer spec 8 to 15 micrometers. I used 8 micrometers per side for my calculations, so because I did a thin coat, so the nominal would be 124.984 millimeters. Now to the scan settings. I did basically 2 passes, or actually 3 passes. The first one was a while back. There I did testing of the marker and tracking mode, and then I did the tracking mode again just a few days ago, because in the first time I didn't perform a fresh calibration of the tracker, because the calibration routine is taking quite a while, roughly 1 to 1.5 hours, and I didn't acutely need the scanner for a project, but now I needed it for a project, so I also calibrated it freshly. I set a target points distance of 0.2 millimeters and scanned until the target quality was reached. It's roughly 5,000 to 6,000 frames, and I then fused and meshed the scans at 0.2 millimeters and did 6 repetitions. For the new scan, I freshly calibrated the scanner, so there were only a few hours in between, and maybe 1 to 2 movements of the tracker itself, but the rest of the settings were similar. Now to results. So basically, what's quite interesting for the marker scans, you can see here I have the 6 scans. They are, I would say the placement of them is quite random. Basically, I think it's using the start point of the handpiece of the handpiece scanning with as a reference for the position. Whereas on the tracker scans, they are quite nicely aligned. I even pulled them apart artificially. So when I loaded all of them into Quick Surface, they were nearly in the same position, or nearly exactly in the same position. Now to the measurement process on how to determine my the rating or the scan results of the scanner. Basically, I import the STL files into Quick Surface, then I extract planes of the anvil and the spindle, so here and here, as primitives, and basically I do use the automatic selection tool of Quick Surface for surface extraction, and I constrain the planes to be parallel to each other. And then I measure the distance between the planes, or more exactly between the two points or edges, how it's called, corners of the planes. Now to the stated accuracy of the tracker. So here you can see the accuracy, the volumetric accuracy of the tracking system is stated at 0.02 millimeters plus 0.04 millimeters per meter. So for the 155mm nominal, this equals to 0.025 millimeters. Now to the results. First, for the marker scan with the marker placement, there we have a mean of 124.98 millimeters with a delta mean of minus 0.04 millimeters. Sorry, minus 0.004 millimeters and a standard deviation of 0.01 millimeters. So this would be well in spec, but the spec is actually for the tracking system. Then to the values of the Trackit in the uncalibrated situation. There we have a mean of 124.743. So there the dark mean is quite large of minus 0.248 millimeters. So this is nearly a quarter of a millimeter. So but the standard deviation is actually quite well. So it's 0.02 millimeters. But since the spec is 0.025 millimeters, this is not very good. So, but keep in mind, this is in the uncalibrated point or uncalibrated state. Now to the values of the tracker in the freshly calibrated state. There it looks a bit different. So these are the values. And as you can see, the mean is now at 125.025 millimeters with a delta mean of 0.041 millimeters. So much better than in the uncalibrated state. The standard deviation is actually the same at 0.02 millimeters, but since this spec is would be 0.02 millimeters, we're sadly not in spec for this test. It could be like I moved the tracker around like 2 times in the same room after calibrating and measuring. Also did the calibration in the afternoon when it was, I would say I think it was like 25 degrees, and I did the actual measurements a few hours later where it was a few degrees colder. So this could be potential influences, but I guess this shows like real world usage quite fine. Now to put the results into perspective, here we can see like all my previous testing with laser scanners. So in the dark blue, we have the nominal line. Then we have like the light green with the marker scan. So this is actually very, very good. So here the 0.004 millimeters that I mean are excellent. And in the dark blue line, we have the nearly black line. We have the tracker scan, the calibrated tracker scan. So what I want you to take away of this video is when to calibrate the scanner or the tracker. Basically, when the tracking quality is indicated as poor, so then calibration is needed. Also after rough transportation of the tracker. So if you like just lug the tracker in your trunk and drive around gravel and cobblestone roads, I would recalibrate the tracker. And also if you have vastly different exterior temperatures. So if you calibrated it in winter and then use it in summer. So basically for me, it was the case that I didn't use the Trackit for like, I think it was like 2 months. So last time I used it, it was 5 degrees in my workshop. And now we had like quite a warm weekend with 25 degrees. So this is enough of a temperature difference that you will notice accuracy differences. So I wanted you to remember that calibration is really needed for high accuracy with the Trackit. And I will also do a short a follow-up video where I outline a bit of the calibration routine for the Trackit and how much time it takes to do and what are like all the steps involved.